Suppose we have an experiment where you want to flip 2 coins. The first thing that we need to figure out is all of the possible outcomes that you could have from completing this experiment. All of these possible outcomes, that is our sample space. One way to do this when we're doing 2 things is to make a table. So here we are completing 2 things because we are flipping the first coin and then we are flipping the second coin. So I'm going to draw a 2x2 table. And on the left edge, I'm going to write my outcomes for the first coin. The first coin, we can either get tails or heads. And then along the top edge, I am going to write our outcomes for the second coin. That coin as well can either be tails or heads. And now, if I fill in the intersections where the values for these match up, so tails, 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 heads, heads, tails, and heads, heads, this will tell us all of our outcomes that we could get back from flipping 2 coins. So this means our sample space is a set S here, and it contains tails, 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 heads, heads, tails, and heads, heads. And the one thing that I want to note here is that the 2 outcomes, heads, tails, and tails, heads, well, they sort of representing the same thing, that one of the coins was heads, one of the coins was tails. They are different in our sample space here, and we need to make sure that we are including them both times because they are 2 different things. Okay. The next one, we want to list the outcomes in the event that both coins show the same side. So both of the 2 coins have to be the same thing, so I'm going to take a look at our sample space and see what outcomes satisfy that criteria. Well, the first one, tails, tails, that satisfy the criteria of both coins being the same. And then we also have heads, heads. That also satisfies this criteria. The next one, we want to list the outcomes that at least one coin shows a tail. So those from our sample space that have at least one tail in them, well, tails, tails is 2 tails, that's at least 1. And then tails, heads, and heads, tails. So we have 3 different outcomes in this event. Another example of a 2-stage experiment is rolling 2 dice. This one is a little bit more work to write out the sample space, so we already have this here. 2 different options of looking at it. The left one is the picture with 2 dice where we see the faces of the die, and you could count up how many dots are on each of them between the red and green. The other one is the one that I usually look to a bit more often instead, is the ordered pair version, where if I just select one random one in here, 4, 3, that means that on the first die we got a 4, and on the second die we rolled a 3. And now with our dice table here, we can add up all of our outcomes, or if you're familiar with multiplication tables, we can take our number of rows and multiply that by our number of columns to get our total number of outcomes for this. So 6 times 36 6 times 6 gives us 36 different outcomes when we roll 2 dice. And now I want to answer a few different questions on this. So we already have the sample space. Let's figure out some different events. The first one being the event where the number of dots showing on the first die is 1 greater than the number of dots showing on the second die. So I'm going to erase the highlighting that I already did on the table. And now I need to find all of the ones where the first die is 1 greater than the second die. Well, the first one I see is 2, 1. So that satisfies this criteria. And then we have 3, 2. 4, 3. 5, 4. And 6, 5. As all of our different outcomes in this event. The next one, we want the sum of the 2 pips, the dots on the 2 dice, to equal 5. So when we're rolling 2 dice and we write out the table like this, there's an easy way to get how many are all of our outcomes that add up to a specific number. So if I look in my first column and I see 4, 1, I know that if I add those 2 together, that gives me 5. If I follow the diagonal going to the right, going upwards, 3, 2, 2, 3, and 1, 4, those will all as well add up to 5. And those are the only ones on the entire table that will add up to 5. So this gives me the things in this event is 4, 1, 3, 2, 2, 3, and 1, 4. And then lastly, all of the things in the event where the sum of the 2 dice equals 9, well, we find 6, 3. Those add together to give us 9. So if I now follow the diagonal, we have 5, 4, 4, 5, and 3, 6. So now those are the only 4 outcomes that will add up to 9 when rolling 2 dice. So this event has those 4 different outcomes.